Hello class. Today I'm going to apply a little bit change to the previous workshop. If you remember from the previous workshop, we created a lot of arrays and matrices, different size, shapes, which may make it a little bit difficult to manage all those many matrices. So today I'm going to repeat the same problem using ANSYS Matlab structures. So let's open new script. Okay, I want to see my previous code, so I changed the view. This is my previous our previous code, and this one is going to be our new one. Like the previous one, let's clear everything first. Then the next step was connections. It is important to find the connections. So now I need to define structure. So P1 is going to be our structure. So P1 is going to be a structure, and a structure is basically it can contain all those different types of the matrices we had. Okay, connections. So connections, this is going to be our connections. Let me paste it here, paste, but for P1. So P1 dot element nodes, and these are all the connections. So this element nodes or the connections goes inside P1. Then the number of elements, let's do it here. This is the number of elements. So again, P1 dot the number of elements. Here I don't have element node, but I have P1 dot element nodes. The number of nodes, P1 number of nodes, which is going to be 4. Then we need to construct different matrices. So let me copy P1 displacement matrix, P1 force, P1 stiffness. So they're going all under that category. Again here, P1 number of nodes for all of them. For the force applied, P1 dot force. Okay, now it's time to construct a stiffness matrix. So P1 dot, this is the local element degree of freedom. I don't need to save it in P1. P1 dot element nodes and P1 dot stiffness, P1 dot stiffness, and the rest is okay. So now it's time for the boundary condition. P1 dot prescribed degree of freedom 134. Okay, I can write the res similar to the previous part, but my plan is to write as a function. So I'm going to have a function which can have some outputs, and it is going to give me those outputs for the calculations. So for the solution, let me copy from here. For the solution, I'm going to define a new parameter. And that function is going to put the solution inside the displacement. So displacement, where are you? Let me copy. So whatever is function is going is whatever function does is going to solve displacement and put inside the displacement of P1. And let's call that function solution this, and it is going to get P1. And let's save this. I don't want to lose. IM3. So we save this one. New script. And what was the name? Solution this. So function. We define a function. Displacement is going to equal this function, which is going to get some p, for example. And what this function is going to do, it is going to does these things. It is first going to find the active node, and I need to be careful. The number of nodes is p dot. I could put the name, for example, O here. So it can. This is going to be O dot numbers and O dot prescribe. But I know I want to assign P1. So that O is going to be P1. Okay. First find active node, then let's solve it. So I'm going to call this, I have many displacement, I'm going to call this U, and stiffness is going to be O dot stiffness, and active this force is going to be O dot force. And so the stiffness, the displacement is going to be saved inside this U. And let's create a empty matrix to save the displacement. Displacement is going to be zeros, and the size is going to be O dot number of nodes, and it is going to be a column. Done. So this is the empty displacement matrix, and I'm going to put U inside that. So this is going to be equal U. But where? I need to say this U is just for active nodes. So I add this parenthesis and say, be careful, I just want to put this U for active node because I solved this displacement just for active node. Okay. So let's save this. Now so this function has an output which we put it here in this, and so because it has an output, we called it here and put whatever the function calculated inside this displacement of P1. Now I need to show the results, outputs, similar to the function we defined. So Control C, Control V, but if you check this code, you can see here there's a mistake because we don't have displacement stiffness. It's too much writing. We did this. We use the structure. So by assigning P1, it is going to automatically transfer all those matrices inside P1. Let's write this, add S here because I need to write another function. Let's copy the name. So this function is going to be a bit different. It doesn't have any like a numerical solution. Function this, which receives for example W, and W is our P1 here, and let's copy the rest from here and then adjust the different parts. So display this displacement, and then W dot number of nodes, and displacement is going to be W dot displacements. Stiffness is going to be W dot stiffness, W dot displacement, and here we calculate reactions, W dot prescribed degree of freedom, which there are basically boundary conditions, and W dot here. So let's save this. Okay, I hope we didn't make mistake in our type or in our considerations. So let's solve it. Okay, now you can see the same results we had here. We can see those results. Let me close these, and we can, if I write P1, you can see this structure has element nodes which there are connections 3 by 2, number of elements, number of nodes, displacement 4 by 1, force, stiffness 4 by 4, prescribed one. So P1 dot stiffness is going to be this. P1 dot displacement is going to be this. So everything is much more organized here. Okay, thank you very much. See you next time.